Okay, so what I did to kind of go over what's on the test with you, I just looked at the non-calculator part that you're taking tomorrow on Thursday, and I just highlighted on the review the things that you'll see on the test. All right, so there's going to be one question where it says write the equation in exponential form given a chart. All you need to look for is what are you multiplying by to go from this term to this term. So it hopefully will be obvious. I don't think it's too hard to figure out what it is. If it isn't, if you can't see it right away, just say all you need to do to figure out what am I multiplying by to go from this term to this term is take this term 4 divided by 2, 2 divided by 1, 1 divided by 1/2, and again this one's probably apparent, which I hope the one on the test it seems apparent that it's 2. So whatever you're multiplying by, that's your base. And then look for when x is 0, that's your start value, that goes right here. So y equals a, b to the x is your exponential parent function. A is your start value, so when you say x is 0, that number goes there for a. And then the base is what are you multiplying by each time to go from one term to the next. And you can always kind of just, once you think you have it, like I have y equals 2 to the x for this one, I might just test it out and say, okay, if I put in a 1 times 2 to the first is 2. That works. If I put in 2, 1 times 2 squared is 4. And once we've made that correction on that, that works. So that's kind of a good way to kind of check it. All right, so do one question like that. There are a couple questions that deal with evaluating logarithms. I picked 6 and 7 to look at. When you want to do these, just set it equal to x and then set it up as an exponential. Your base 6 raised to the x power has to equal this number. And if you see 6 to the x equals the square root of 6, there's a couple things you need to know about exponents, that when you see the square root, you need to know that means 6 to the 1/2 power. So that is the same as 6 raised to the 1/2. So if 6 to the x equals 6 to the 1/2, then I know x has to be 1/2. These bases have to be the same in order for you to do that without a calculator. So on this part, they will definitely be the same. Look at this one, 9 to the x. So if I set this equal to x, 9 to the x power equals 1 over the square root of 3. So I need to get these as the same base. So I write 9 as 3 squared, so that's 3 to the 2x. This is the square root, so that's 3 to the 1/2, but because it's in the denominator, that also means it's a negative exponent. So it's 3 raised to the negative, because it's in the denominator, to the negative 1/2, because it was the square root of 3. So then I see that 2x has to equal negative 1/2 when the bases are the same. Set them equal to each other and solve. So there's one question like that, just making sure that you can first, and it'll be partial credit, can you put it into exponential form if you can get to that point, and then it'll be a matter of do you know your laws of logarithms, or your laws of exponents, sorry about that. Like, do you know what that when you have a radical, you have a fractional exponent. So the square root of 3 is 3 to the 1/2. Do you know when you have a base in the denominator, it means your exponent is negative. So those are the things that would be like for the second point, or part of that problem. Okay, then I went down to number 11. There's one very similar to this that says you have to find the domain. All right, so when I look at the domain of any of these that you had to do on your worksheet, you just set what you're taking the log of, no matter what it is, no matter what the base, whatever you're taking the log of has to be greater than 0. That's what the domain of a logarithm is. And again, if you get to that point, that's worth some points, that you understand that logarithm has a domain of whatever you're taking the log of, that domain has to be greater than 0. So then it becomes algebra issue, and we have done several of these, and you'll be doing a lot of that in calculus. So I think this is an important one to look at. So remember what we do is we say, okay, where does the numerator equal 0? Well, equals 0 when I put in x is negative 1. So I put negative 1 there, open circle, because it's just greater than 0. Doesn't include it. Where does the denominator equal 0? At 5. So I draw a circle around 5. So I draw my number line, I draw circles around where it equals 0. And in either case, it can equal 0. So I open circle that. And then you just pick points. Pick a point down here, like if I picked negative 2. Negative 2 plus 1 is negative. Negative 2 minus 5 is negative. A negative divided by negative is a positive. I put a number in here like 0. I put a 0 in, I get 0 plus 1 is positive. 0 minus 5 is negative. Positive divided by negative is a negative. And then if you put something in over here like 6, you get a positive over a positive. And so I'm looking for all the places where that fraction is positive. So I'm looking for the pluses, so it's everything to the left of negative 1 and to the right of 5. And so to write that, I either can write it algebraically and say x is less than negative 1, or, you have to use the word or, x is greater than 5, because it can be in either of those spots, so either or if you put it in interval notation, it goes from negative infinity, because it starts over here, to negative 1, not including, so it's a parentheses, union, that's what or is also means, union, parentheses 5, comma, infinity. So from negative infinity to negative 1, not including the negative 1, and from 5, not including the 5, to infinity. And that's a union or the word or, if you do it algebraically. Okay, so kind of look that one over. Big issue with logarithms is you know the domain is greater than 0, but then it becomes some algebra that you can solve it. Okay, and then another one that I think you should look at is number 16. Remember, you need to recognize that even though these bases are e, and those are just numbers, that this is a quadratic. So I am going to look at that and say, all right, I know this. If I take e to the x and square it, I get e to the 2x. So if you need to do u substitution, just say, all right, that's my variable. I'll call that u. So if u equals e to the x, then this term is u squared. And that makes sense. If I square both of these, I get u squared. Here I get u to the 2x, because when you raise something to a power, you multiply. So that will be your x term, your u term, and that will be your u squared. So then if you want to do it that way, you would say, all right, this really means that I have u squared minus 3u plus 2. So some of you do it that way. You solve this for u, but then you always have to plug that back in. Others of you can look at that and say, all right, I know e to the 2x is really just e to the x times e to the x. That gives me e to the 2x. To get a plus 2, I'm going to take a minus 1 and a minus 2. They multiply to give me 2. But now my middle term will be negative 3 e to the x. That's how many e to the x powers I'll have. So you either can just factor it as is, or you can use that u substitution. Then you set this equal to 0. So if I set e to the x minus 1 equals 0, I get e to the x equals 1. Well, what power of e do I raise that to get 1? Anything raised to the 0 power gives me 1. So that's why I know that one without my calculator. This one, if I set that equal to 0, I get e to the x equals 2. I can't do that without a calculator, so all you really can do with the calculator is convert it to log form. Log base e, which is natural log, of 2 equals your exponent x. So log base e, natural log of 2 equals x. Okay, so you need to recognize that's a quadratic. I don't know if quickly I can look here. There's one other log problem. Know the properties of logarithms, that you have the log, this log minus the log of 2. So you can combine that as a quotient. When you're subtracting two logarithms, it becomes the log of x plus 1 divided by 2. Equals still the log of this. Once you have two logarithms equal to each other, those two things have to be equal to each other. So if the log of this equals log of this, those two things have to be equal. So up here I did that. 5x plus 1 has to equal that fraction. I multiplied both sides by 2. Then I subtracted x, subtracted 2. And remember, if it's 9x equals 2, I have to divide by 9. So I get x equals 2/9. You should always plug it back in. 2/9 plus 4 is okay in the domain. 5 times 2/9 plus 1, that'll be okay. It'll be a positive. It's in the domain. So just make sure when you plug it back in, you aren't taking the log of a negative. And then real quick, number 22. Remember, the carrying capacity is just that number, whatever that number is. So carrying capacity is 42. To find the initial value, you put in a 0. So you take 42 over 1 plus 3 times 0.2 to the 0. Anything to the 0 power is 1. So I got 42 divided by 4, which was about 10.5. Okay, so that was kind of all the log stuff that's on the test tomorrow.